Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see increasing and decreasing functions, applications of derivatives part 3, and in increasing and decreasing part 2 it is. Okay, already I have uploaded one video based on increasing and decreasing where even I have said about answer keys. Okay, we have also discussed the answers for first 15 questions. Still there are a few questions, 15 to 14. Okay, so now we are going to discuss next part. Actually, increasing and decreasing, extremas, these two are kind of big topics. So even for extremas I might be taking two videos or one video, but I personally feel like extrema is kind of less a small topic. Okay, is smaller than increasing and decreasing. Okay, so we shall get started with this. Last video we have seen everything, okay, that is required for some NCERT exams, but there are some questions where we all might be having some problems. So in that case, we are going to discuss those problematic questions. Okay, so I will first recommend you all to go and watch that video, then come to this video. And this video's duration is going to be very less, maybe 30 minutes to 20 minutes only. I personally think, I don't know how much time I'm going to take for this, but it is going to be very less only. Okay, so let us find this question. We will start with the question on B. Okay, so you just put, okay, and then they are asking us to find whether is this function increasing or decreasing at x is equal to 0. At x is equal to 0. Okay, so see, first you will have to differentiate this function. That means f dash x is equal to 3x squared. Okay, so now you have to put f dash of 0 is equal to 3 of 0 into square, so it is 0. So now you have to plot a graph. X is equal to 0. Here it is going to be positive, here it is going to be negative. Okay, here it is positive, here it is negative. See, at this point now you have got f dash, okay, f dash x is equal to 0. Now what will you be doing? Now what will you be doing? You cannot do anything. Here it is not greater than 0 or it is not less than 0. Here it is equal to 0. This is the scenario where many of us will be having some confusions. But if we all have understood previous concepts in a good way, then answering this question is pretty simple. What you have to do is, in this condition, you will have to check nearby points. Check, okay, check nearby points. Okay, so you will have to check the nearby points. When you are checking nearby points, automatically you will be getting answer here. Okay, so you have to check nearby points. How will you be checking the nearby points? So that means x nearby points can be this. Okay, this can be, and then also this can be x nearby points. Okay, so this, and you can see that any point that you put, for an example, even if it is like it can be like minus 0.0001, even that is a nearby point. Then here also plus 0.001. No matter what, even if you just change one point, okay, from here automatically you'll be getting negative, and here you'll be getting positive. So automatically see, and also you will have to check. Okay, now you are checking nearby point. Here you are having what? Here you are having square. So that means what? This total term, okay, this f dash x is actually going to be always, okay, this f dash x is going to be, f dash x is always greater than 0, because even if you put this term here, okay, like f dash of x minus, okay, this is also greater than 0 because of the square, and also f dash of x plus is also going to be greater than 0. So where after concluding this, only you will have to conclude this. You cannot directly go and conclude this. That's wrong. Okay, that's not correct. You will have to conclude this, then at last, after as conclusion, you can write it like this. Okay, so this is one thing. Now, okay, now see, this is what these two are. Okay, both f dash plus and f dash minus are actually positive. Okay, so this is actually a sum. From this we can see that when these two are positive, so when both f dash of a plus and f dash of a minus are positive, positive, then okay, then f dash of A is increasing. Okay, so this is one thing. Then secondly, then you might all have a doubt. Then what about when f dash of A plus and f dash of A minus are negative? Both are negative. When both f dash of A plus and f dash of A minus are negative, okay, negative, then in that condition, okay, okay, when f dash of A is what? Here it is decreasing, increasing when I wrote, okay, perfect. Here it is decreasing. Okay, then also one more condition is there. Now when these two are opposite in sign, so when f dash A plus and f dash A minus are opposite in sign, okay, are opposite in sign, then f dash of A is neither increasing, and nor decreasing. Okay, and nor decreasing. Okay, so this is your example. So we can also see another example. Okay, what did I say? Here this is actually increasing. So that means for decreasing, all you have to do is to put a negative sign. We will do that sum. Okay, we will do that sum itself. Okay, so this one is where f of x is equal to x cube. Okay, then what about f dash of x? F dash of x is equal to, minus x cube. We are taking minus now. Okay. Then f dash of minus x. Okay, f dash of x is equal to minus 3x square. This is something you are having. Okay, so again, okay, at x is equal to 0. They have also given the question that at x is equal to 0. At x is equal to 0, you will have to find. Perfect. So plot the graph. X will be 0. Okay, at 0 only. If you are putting here, this is negative. Okay, here this term, no matter what, is going to be positive. Okay, but since you are having a negative, so the entire term is going to be negative. It is going to be negative. Okay, so when you are having both in opposite sign, just divide it by x. Any linear equation you can have, but that should not have a constant. Okay, that should not have that c. Okay, that constant. For an example, you can have here example for this one can be f of x is equal to any constant into x. That is a great example for here. Okay, any constant into x. Okay, and also x should be 0, and also x should be 0 at x is equal to 0. So in that condition, what is your f dash x? Any quadratic equation you can have, but okay, this one, but you should not, you can also have any constant, okay, plus any constant, plus any c. Okay, so f dash of x is equal to k2 into x plus 0. But the thing is here plus that x should not be there. Here it is a constant. Here this constant does not have any x. For an example, you just take that f of x. Okay, you don't take this. This can be quite confusing for many of us. plus 4. Okay, this is known as depressed quadratic equation. Okay, actually there is a trick to find the factors of this quadratic equation. For that you have to change any equation from its general form to depressed form. This is actually known as, see, you don't have x, you don't have that plus x, right? You don't have that plus 4, that kx, you don't have that plus kx. Okay, so this is known as depressed quadratic equation. Okay, this is actually a very big theorem. We don't have, but it is a very big theorem. It is not a theorem, it is a very big trick. Okay, so now you are having like this. Now it's f dash x. It's f dash x is equal to 6x plus 0. Okay, so 0 we will take. Now you have to all you have to do is to put, see, at x is equal to 0 now. Here only 0, here minus, here plus. See, both are there. Okay, here both are there. So what it is? It is neither increasing nor decreasing. So hence it is non-monotonic. Yeah, it is non-monotonic. Okay, so we have already done lots and lots of sums. Okay, really lots of sums we have done. Now we have to do one thing. Wait 1 second. Okay, one note point we are having. I will check whether do I have any free space. No. Okay, so one note point. Note. Okay, this is actually one-sided inequality. We have seen one-sided discontinuity, sorry, one-sided continuity, one-side differentiability, not one-side differentiability we have not seen, but one-side continuity. Like that we are going to see one-sided, okay, inequality. Okay, actually inequality. One-sided, okay, one-sided increasing and decreasing. Okay, one-sided thing. This is one-sided. Okay. Wait. Now you check here. Now you all have to do is to check here. See, in this condition the graph is actually increasing. Okay, so you don't have a minus h, and hereby you don't have a plus h, isn't it? You don't have here a minus h, and here you don't have a plus h. So what you will be doing actually here, okay, the domain they have given us here. Okay, exactly in the boundary point you will have to check. Okay, in the boundary point you are actually asked to check, and here also same thing. This is actually another boundary point. Okay, this is another boundary point. So in this time what you have to do is, all you have to do is here f of a should be wait, this is actually will be keeping it as, we shall keep this as to be x and then x1, this has to be x1 and then x. Okay, so this x here, note x x should be greater than x1, and then f of a should be greater than f of a plus h. Okay, so f of, okay, here also see x1 should, sorry, wait, is this correct? No, this is wrong. Here it should be x1 should be greater than x, and then f of a plus h should be greater than, okay, f of a plus h should be greater than f of a, then it is known as increasing. Here it is x, but f of a minus h should be greater than f of a. Okay, a. So in this case, this condition you will have to check, then it is increasing, then it is increasing, and then here, then it is decreasing. Okay, so yeah. Okay. And also, yeah, that's it. Then what else do we have? Okay, so monotonicity in an interval. What about monotonicity in an interval? What about monotonicity in an interval? Monotonicity in an interval. So hereby we are having increasing functions. Okay, a function f is said to be increasing or non-decreasing. Yeah, by the way, increasing can be said as non-decreasing, decreasing can be said as non-increasing. Okay, that's also correct. Like for an example, I don't like it. Okay, for an example, I have something. Okay, we will take about what I don't like it. I like all the food. Okay. Okay, so we will take curry. In here it is known as ragi ball in English, but it's very healthy. No offense, my mother loves it, my father loves it, everyone loves it except me and my brother. Okay, because for me it's like, no, I cannot eat it. Okay, so I don't like it. It doesn't make it as I hate it. I don't like him, okay, or I don't like her, or I don't like it, doesn't make that I hate it. It is just like I'm not preferring to be with it, or if I'm just not, yeah, preferring to be with it. It doesn't make like if I have it, okay, if I have it with me, okay, no problem, but I don't prefer, that's it. Okay, I'll prefer some other thing. That's what it is. Okay, like that only. Increasing functions are also called as non-decreasing functions. Decreasing functions are also called as non-increasing functions. Okay, so here we are having increasing and then non-decreasing in an interval. Okay, in an interval. So for an example, we will just take, okay, any graph. Okay, any graph. We shall take, for this increasing, what graph have we taken here? Okay, we will take this graph. Okay, so the condition in an interval, so they are asking us to find whether is this increasing or decreasing in this particular interval. Okay, so in this particular interval, generally they will not be asking, because this has like for an example, what I'm saying is, here in this condition it is okay, but if the graph is like this, then what will we see? Wait, I will prove it. I will first prove this condition, then we will be going to that condition. See, like this, you are having in this particular interval, they are asking us to prove whether is this increasing or decreasing. Just by looking, we can say that it is increasing. Okay, so see, x1 is less than x2, okay, is less than x2, then here f of x1, okay, f of x1 also should be less than f of x2, should be also less than f of x2. Okay, so see, you can see that, and also it can be equal. Okay, then it is actually increasing function. Then what it is an increasing function. Okay, so it is an increasing function now. Okay, but what if your graph was like this? Here it is e to the power of x graph, you can just like that we can say. But what if your graph is like this? Here we cannot say anything that it is just increasing, because you take here it is, here it is, here it is increasing, here it is decreasing. So what? Okay, so this is actually generally they will not be asking us, and even if they ask, they will be giving us a plain function like this only. They will not be giving in center, there will be a point where it is like that. That is not something in our topic, but if they are giving in that sense, we have to be prepared, right? So I'm just saying, so, but this thing they will not be asking. If they ask, also not a problem. See, monotonicity in an interval, even in NCERT sums we have did few, okay, even in our NCERT sums we have did few, and in that it will be very regular. Here it is a regular graph. But when I draw something like it becomes as an irregular graph, and they'll not be giving us irregular graphs that much. If in NCERT not possible according to me, maybe in JEE they might, and I don't care because I'm not a JEE student. Okay, next is decreasing functions. Then what about your decreasing functions? Same thing only. Okay, so here it is what f of x is equal to, okay, f of x is equal to e to the power of x. Now then here we will take f of x is equal to minus e to the power of x. Okay, so we all know that x1 is less than x2, but for decreasing this is a very special condition. Okay, for decreasing this is a very special condition. That is, it will be exactly opposite. Not only here, even in before cases we have seen seen the same cases, but I did not mention this particular thing for decreasing. Okay, f of x1 should be greater than or equal to f of x2, and here also the same thing only. That same drawback is here. What about like this? Okay, what about like this? Okay, that's something that is what they will not be saying, I said. Okay, so then by the way, one thing I have to say, that is even constant function is also an increasing function only. Okay, constant function is also an increasing function. I'll be saying why. See, whenever you are having like any function, you have any function, there will be f of x. That any function be f of x. Okay, so when you're differentiating it, it can be greater than 0, or it can be, so okay, it can be less than 0 or it can be greater than 0. Okay, so that will be f dash of x, and here also it will be f dash of x. Okay, where it is greater than 0 or also equal to 0. Here also the same, it is less than 0 or equal to 0. Okay, so these two are those typical conditions that we can get. Other than this, we cannot say anything. Okay, so here what does it mean? It means that it is either decreasing. Okay, it is either decreasing. It is either decreasing, or else it is strictly decreasing, Okay, same thing only, even here they will be saying. Okay, or strictly decreasing. Okay, here also same, increasing or strictly increasing. Okay, so these are those two different possible cases. Okay, so first we will be talking about decreasing. Okay, so here I will be taking one example. Let the color be this. Okay, here just decreasing is f of x is equal to is where f of x is equal to -5 or any constant. It can be or constant. Then that means what here? You have to multiply just minus. Then you will be getting f of x plus is equal to +5 or any constant. Okay, we shall take constant. Okay, then hereby strictly decreasing, right, and strictly increasing. What are those? Quadratic we cannot take, but we can take cubic, or we can take also exponential. Since till now we have taken only exponential, now we shall take cubic. Okay, so f of x is equal to minus x cube here. Then here it is going to be f of x is equal to, okay, f of x is equal to plus x cube. Okay, it is going to be plus x cube. Now here the difference we are talking about decreasing and strictly decreasing difference, and we are talking about the difference between strictly increasing and then just increasing. That's the difference that we are going to talk now. So for decreasing, okay, for decreasing, inequality occurs in an interval. Okay, sorry, equality occurs in an interval. Equality occurs in an interval. For an example, we will just take a graph. Minus k. Okay, so here it is minus k. Okay, so this is where, see, you can see that in this entire interval, it is what? It is equality. Equality is occurring in this place. Then, whereas for strictly decreasing, okay, equality does not even occur. Equality does not occur. Where you can see equality? No place you can see the equality, isn't it? Okay. Then what about here? The graph is going to be same only. The graph is going to be not same, little bit of difference, but same only. Okay. So this is going to be k, and here in this place equality occurs in an interval. Okay, equality occurs in an interval. Then hereby here equality does not occur. Okay, here also equality does not occur. Equality does not occur. Okay. Also equality does not occur. Also equality does not occur. Okay. So now I'll check. Oh, exactly we are here in this slide. We are exactly here in this slide. What a great coincidence is this. So we have completed in last place till here. Now we will just do 14th and 15th. Then we will end this lesson. Sorry, then we will end this exercise. Then we'll be going to the next exercise, which is one of the most lengthiest exercise. And I hope we have time. Okay. With that, okay, like We have some time. No problems. No problems. Okay, so that exercise I will complete very soon and you can all watch the video. Okay, so what about this question that they have given us? This question, oh, we have completed also. This one also we have completed now. Okay, let I be any interval. That means I is an interval. It can be any interval from -1. Okay, interval disjoint from -1 to 1. That means what? It is disjoint from -1 to 1 means what? I is an interval, but exactly in this interval, I is disjoint. Okay, exactly in this interval, I is disjoint. That is what? Okay, that is what in this interval. That means, for an example, if I is this one, okay, this is what the graph for I is. Okay, then exactly from here, okay, from -1 to +1, okay, I is disjointed. This is the domain. Okay, this is the domain where I is disjoint. Prove that the function f, okay, prove that, and also we all know that a function need not to be differentiable or continuous to be increasing or to be decreasing. Okay, so okay, prove that the function f, okay, f, that is what this function, okay, that is what this function is actually increasing on I in this particular thing. That means what? I is equal to, okay, I be any interval. So let us take that I is, okay, all real numbers. Okay, I is all real numbers, but excluding, okay, but excluding from -1 to 1. We shall take like that, right? Okay, now that means here in this particular, in this place of x, you cannot put any real numbers that is from -1 to 1, and note -1 and 1 are included over here. Okay, I don't know why am I saying this much, but you know I have not done the sum, so that is why I am kind of anxious whether can I do it correctly or not. Let us check. Okay, first we have to differentiate it. Then it will be f dash of x is equal to 1 plus, okay, so 1 plus, what is this? This place many of us make it wrong. Okay, what is this? This can be written as x to the power of -1, right? Now, okay, -1 x to the power of -2. That means what? It is -1 by x squared. Okay, this already was said in differentiation itself, but it's okay. So here it will be minus, here it will be -1 by x square. Okay, so this is something that you have. Now what are they saying, guys? They are saying that, okay, they are saying that here we have to prove this entire thing as increasing. Okay, it is actually increasing. Okay, so then just equate. So x is equal to 0, x should not be equal to 0. Okay, x should not be equal to 0. Okay, so we have also equated it. Now wait. One second. Instead of doing like this, we shall do it like this. Okay, f of x is equal to x plus 1 by x. Okay, now we shall differentiate it. Then f dash of x is equal to, okay, here this entire thing will be 1. Okay, 1 into x minus x plus 1 into 1 whole divided by x square. So that means what? F dash of x is equal to x minus x plus 1 by x square. Exactly the same thing only you are getting here also. Not a problem. Okay, so here it is 1 by x square. Not the same thing with some difference. Yeah, here there it was 1 now. There it was 1. But how is this possible? X minus x minus 1. X minus x minus 1. So which means am I getting x square? Drama. This is what? Some basic problems. Okay, so now if you differentiate, now you can differentiate it. Now everything, actually f dash of x should be the same thing. That was the thing that I was wondering. Okay, so f dash of x is equal to 2x, okay, into x plus, sorry, minus, okay, so 1 into x square plus 1 whole divided by x square. So what is this? This is 2x square minus x square plus 1. So hereby it is going to be so we will just take it as 2x square minus x square plus 1 whole divided by x square. So at x is equal to 0, it is 0. Then also where x is equal to 0, first we will have to check, but x cannot be 0 according to this equation. X cannot be 0. And also see here, this is x square plus 1 is equal to 0, so x minus 1 there, so minus 1 also cannot be there. Okay, so also x should not be minus 1. X should not be minus 1. Actually they are asking us to prove it is strictly increasing only, right? So that means you can take x square plus 1 should be always greater than 0. Okay, so x square is actually always greater than 0. See, what have they given? What is this? This is x square, and you can see that x square plus 1 only. Now we have x square plus minus 1 is equal to x square minus 1 by x square. Okay, now you just check. X square minus 1 we have. Okay, x square minus 1. I don't know why am I being confused for this basics. Okay, then also we have x square. So x square is always greater than 0. That is something we all know. And x square minus 1 is also always greater than 0. It is also greater than 0. Why? Because for an example, one and only if x were 0.5, then okay, then it will be then this will be negative. But they have clearly given us that okay, this x cannot be any number from minus 1 to 1. So that automatically makes this as positive, this also positive. So automatically what is this? This entire thing is positive. So f dash x is positive. So if f dash x is positive, that means what? F dash x is greater than 0. So hence it is greater than 0. It is strictly increasing. Okay, it is strictly increasing. Okay. Strictly increasing, but only in the absent of. Okay, but only in the absent of. Okay, but only in the absent of. Only this should not be there. Okay, so you have to prove it like this. You can prove it like x square is greater than 1. Just take it this side. Okay, then x square is x is plus or minus 1. So you can have to take this as two cases. X is greater than plus 1. Okay, then x minus 1. Okay. Minus 1, 1. Okay, like this. Then here also like this. You will have to take union. See, this is the common shaded area. So from minus 1 to plus 1, you are going to take. Okay. See, I know I have not done this sum properly. We will do it again. Then we will end this video. Okay. So we have got our f of x. Okay, we have got our f of x. Our f dash x is actually x square minus 1 by x square. Okay, this is our f of x. Now they are asking us to prove it. Okay, so to be increasing, what is this? To be increasing, it is x square minus 1 should be always greater than 0, and also x square should be always greater than 0. This is a factor. Okay, because 0 is not there. Okay, perfect. So this one is proved, but this one you will have to prove. See, x square plus 1. Okay, then plus or minus 1. Okay, so that means what? Okay, so x is actually greater than plus 1, and then x is actually greater than minus 1. Now plot the graph. Now when you plot the graph, you are having minus 1, then plus 1. Okay, what is this? X is greater than 1. So that means x will be any number from here. Okay, then here what is this? Then this is actually x is actually greater than minus 1. So x can be any number here. Okay, so you have to actually take what? You will have to take the intersection. Plus na intersection na. Sorry, union na. See, when you're taking minus 1, it is the negative, so we will have to change the sign. We will have to change the sign. So, which automatically makes, wait. Yeah, whatever I said is correct. You will have to take the intersection. Okay, intersection or union now. Intersection of the common area you will have to take. Union you will have to add. See, they have but clearly given us in this condition, actually here you have to take the other sign only. Okay, you will have to take other sign only. Why? Because you are taking here minus 1. If it because we all know this now. That is x is greater than 1. Okay, x is greater than 1. Now you are multiplying minus. So then automatically, it will become. So for minus 1 you will have to take the opposite sign. So okay, so when you are taking it like this, so what is it? It is actually x. So automatically this becomes as x is greater than so it will be 1 comma infinite. Here also it will be minus 1 comma minus infinite. Then automatically you will have to put your union. Okay, so here you can write it as this thing can be written as real numbers minus 1 comma plus 1. Okay, so yeah, that's it for today's video. We will be meeting in another amazing video. Till then, bye bye.